pause. Hi students, it's day 2 of pre-algebra, and today we're going to talk about algebraic expressions. And so there is some important vocabulary. If you've been at the Excel Center for long and you have taken Math Foundations, this may be review for you. But for some of you, it may be new words, new language, new vocabulary. And so I want to be sure that we are all on the same page. So hopefully we understand one another. So a variable, in our case, we will use letters that represent unknown numbers. We're going to use the normal English alphabet, but please keep in mind that it could be Greek letters, it could be some other symbol, but it's just something that represents some unknown number. We'll stick to letters that you're probably accustomed to seeing. And the next word that we're going to look at, constant. A constant is a value that does not change. It's a regular number. That's kind of an easy way to think of it. It's just a number. And then, the number 3 is always 3. A coefficient is a number that's going to be right in front of a variable. And it's going to be right in front of the variable, which means that it is being multiplied by the variable. Right? And as we look at these, you'll see examples of each of these. And then simplify means make it less complex. And in the case of math, that typically means it's going to be smaller. When we give an answer and it's simplified, it's typically smaller. It's less complex. We're going to pack up everything as much as we can. And we're going to do that. One of the ways we're going to do that is by something called combining like terms. So we will combine the like terms. And to do that, we're going to be adding the coefficients, but keeping the variable the same to shorten algebraic expressions. Like terms means that they have the same variable, and if they had exponents, they would also have to have the same exponent. So typically, at least initially, we're going to be combining the variable terms and the constant terms. And the variables, if there's more than one variable, we can only combine the ones that have the same letter, the same variable. So if we thought of A representing apples, B representing bananas, then it's kind of obvious then to see that 2 apples plus 3 bananas plus 3 apples could be simplified to just say, hey, 5 apples and 3 bananas. So we could simply say 5A plus 3B. By the way, if you chose to write 3B plus 5A, it's still equivalent, and it's okay, but typically we'll see it written in alphabetical order. So on your next page there, you'll see an example now. We've got X's and Y's, and there are the signs in between them. We typically think of those as being addition and subtraction, but rather than think of it as so much addition and subtraction, think of it as being the sign of that term. And if something is just an X, just like if on the last example, if we had just an A, it would have meant 1 apple. So if we see a lone variable without a coefficient, it's understood that its coefficient is a 1. And if it helps you to write that 1, you certainly can. So back to this example, it's already worked out for us. And you may or may not choose to write down this step. All right, so you might choose to write that. That might just be something that happens in your mind. Um, for that matter, you may or may not like to circle things and box things. So that's just how this is showing which ones are like terms. It would not have had to be rewritten. I could have simply done 4x and negative 2x. And then I could have done circles. Not very well, apparently. Circles around these two. So much for me trying that technology. So nothing magical about X's being in circles and Y being in boxes. And again, just be careful that if you do circle the original problem, that you can see the signs, because that was going to be my trouble there. So it's also okay, and as you get more accustomed to it, you may find yourself doing this. Just kind of looking at these two, and in your mind, 4x and negative 2x, 4 minus 2, that's 2x. And I would just go and write down 2x. And then I would go back to the problem, 3y and 7y. They're both positive, so I'm just going to add them together, is 10y. So I'm not trying to create a lot of extra work for you. This makes it look like you need to rewrite the problem and make circles and boxes, and then regroup, and then write the answer, and then write the answer again. It's just like some of this would be thinking. So it may be very helpful to circle or underline, and maybe underline twice when you're doing the other like terms. If it is helpful for you to rewrite it like this and like this, it's perfectly fine. But please know, it's not required to do that. That's kind of, when we're looking at something that's typed out, sometimes we need, in case I didn't make a video and you're just trying to figure it out, so that you can understand the thinking process. So we have some examples here, and I do see some that just have a variable. So let's see, I'm going to go down kind of through that middle column. So a plus 3a. So remember that that's like a 1a. So 1a plus 3a is 4a. The b at the front, it had a dot beside it. It's just like numbering, lettering the problems. So here I have a 1x and a 3x, so they can put together to make 4x. And then we have a positive 2 and a negative 1, so plus 1. My writing is not so great tonight. So the sign only goes on what immediately follows it. So over here in D, where it says 9 minus 6w plus 2, that minus sign is only on the 6w, all right? So the 6w is negative, and there's no other w's, so he's going to stay negative 6w, and then 9 plus 2. So plus 11. So the minus doesn't get applied to the 2. It's only on the 6w. You could have more than one variable. And to go back to the fruit example, we're not making fruit salad. All right. So if there are multiple variables, you can only put them together if they're the same. So like in G, 3x and negative 6x, negative 3x, 4y and 2y, positive 6y. Even if it's positive, we need the sign so that it keeps our terms apart. Okay, so there are some other examples here. Sometimes M and N look so close to one another that they accidentally get added, but those are different letters. And just gonna write some of these down quickly, and then you can kind of pause and see if hopefully we agree. In H here that I just did, we have 3 constants. So the 4, the 2, and the -3 are all constants. So 4 plus 2 is 6, take away 3, makes 3, and y is already there. Typically, we'll write our constants at the end. Again, you could switch the order and it's still equivalent, as long as if there's a negative sign, you keep it with the term that it's with. So if I wanted to write D in a different way, that's equivalent, I could write 11 minus 6W, but notice the negative sign needs to be in front of the 6 because it belongs to the W. If we have a pair of opposites, since opposites add up to 0, if we have a pair of opposites, like this 2x and -2x, our answer just won't have any x's at all. So just 5 plus 7 is 12. I don't want to write 0x, just 12, simply. All right, fantastic. So that is combining like terms, and the directions would typically say simplify. And I think you could agree that our final answers did look simpler, less complex, shorter than the original problem. And so the next page, page 10 of your packet, is an assignment page. And then you have another example on that same page that you can look at. Obviously, you can go back and look at your other examples that we just looked at too. And then we're going to go ahead on the same day, also part of day 2, we're going to look at distributive property. So in order of operations, we are told to do parentheses first. But if inside the parentheses, I have something like x plus 3, and they are not like terms, I can't add them together. And so since I can't add them together, I need another way to get rid of those parentheses. So I kind of think of the parentheses as if it's like a lunch bag. All right. So for instance, if you thought about our apples and bananas or whatever, our X's and our 3's, if I had some little plastic X's plus $3 and I had it in a bag and I had 4 of those bags, and I want to know how much I have, what do I have all together? If I just emptied things out of the bags, I would have 4 of the X's and $12, because 4 times the X and 4 times the 3. So when we want to get rid of the parentheses, we're going to multiply that number that's right up against the parentheses, or it might have a dot like in the other example below here, times everything inside the parentheses. In this case, I'm saying both, but it could be more than 2 terms. So if I had A times B plus C, that's the same as A times the B plus A times the C. You can multiply things that aren't like terms, in case that brought on a question in your mind. We'd probably be more likely at this point to see something like the second example with 3 times X plus Y, 3 X's plus 3 Y's. So we're taking what's on the outside and multiplying it by what's inside. And then on our last row here, we will, after we have done distributive property, we will also combine like terms. But first, we'll just practice some distributive property. So again, sometimes my students call this, they're going to make their rainbows. So 4 times the x, 4x, 4 times the 2, so 4x plus 8. You don't have to draw the arrows or the lines across there. I just typically draw those for a while at least to help people visualize what's going on. So 3 times 2x. So you might even see this written this way. Sometimes if someone's trying to show all the steps, this would be a thinking step though. I would think 3 times 2x, and what I would write down would be 6x. And then I would think 3 times 3, and I would write down 9. I don't usually write this step, and I don't expect you to write it. If it's helpful to you, you can write it, but it's not necessary. So in C, we have a negative number on the outside. And so we need to think about multiplying both things inside, both terms inside, by -2. So -2 times x, -2x. Then -2 times 3, -6. And these are finished at that point because we're not solving. If you know about equations, we're not solving, we're not there yet. Give me a couple more days. We're not solving these, we're just simplifying. There is no equal sign, so that's why we can't solve. All right, second row. Now we have a negative on the outside, and I want to get your attention. Please be sure you catch this, because this is a common kind of problem that people make mistakes on. So when I do -5 times x, that part's not the hard part, -5x. The next part, though, is very important that we consider this as -5 times -3. So when I multiply two negatives, what happens? Yeah, I multiply two negatives, I get a positive. So this is positive 15. So just be careful of those signs. 6 times x, 6x. 6 times -2, -12. So again, you can draw the arrows. That may help you get used to what's going on, kind of visualize that. You can write it out like I did in B. If you're writing it out, starting with F, we have some extra steps. So just to warn you. So this becomes 2 times x plus 2 times 2. Again, that would be something thinking in my head. I would probably then just write down 2x plus 4. Either way, this plus 2 on the outside is still hanging out here. So now I have 2x plus 4 plus 2 more. Then I need to combine my like terms so that my final answer is 2x plus 6. Again, this part is probably just in your head. It was just as easy, instead of writing that down, to write down 2x and then write down 4. So sometimes if you look for help online, you might see that step written out. But to be honest, no one, well, I shouldn't say no one, but very few people who understand the process write that step down. That's just because if they're trying to show you the steps without talking to you, they're trying to show you what should be going on in your head. So in G, remember that parentheses and multiplication come before adding. So we need to distribute first 4 times x, 4 times -3, and the -3 at the beginning just comes down and waits. He's going to get added on the next step. Do not do -3 plus 4 first. Now we can combine like terms. There's only one term that has a variable, 4x. 4 would be the coefficient of the variable. And then -3 and -12 are like terms. We can add those together. They're both negative. That gives us -15. Okay, in H and I, we will use distributive property twice and then combine like terms. So first, 3 gets to multiply times x, so 3x. We're going to distribute the 3, and 3 times 2 plus 6. Then we're going to distribute the 4 times this x. So it's positive, so plus 4x. And 4 times 1 plus 4. Now our parentheses are gone. And so now we need to combine our like terms. So the 3x and the 4x, 7x, and then the plus 6 and the plus 4 makes plus 10. All right, so pause the video. Try the last one there in the corner. Be careful with your negatives. And then restart the video to see if we got the same thing. Did you pause? All right. Here we go. So I need to multiply by -2. So that makes this -2v. And then -2 times -3 plus 6. And then it's -4 times v, so -4v. And -4 times -1 plus 4. Then we need to combine our like terms. So -2v, -4v makes -6v. And plus 6 and plus 4 make plus 10. All right, I hope that's what you came up with. So that is combining like terms and distributive property. And those last problems, we did have to use both combining like terms and distributive property. And so now you see you have some practice. Again, the directions will say simplify. So some of them you are just distributing. I do want to point out number 6 because we did not have an example like that. So number 6, there's just a negative sign. So we can think of that in a couple of ways. Some of my students like to think of that as meaning -1 and then multiply by -1. Or when you just see a negative sign there, you can think it means the opposite. So the opposite of 7 is -7, and the opposite of -a would be +a. So when we have, and if we did -1, -1 times 7, -7. -1 times -a, +a. Same answer either way. So just know if there's a negative on the outside of the parentheses, when we get rid of the parentheses, everything inside is going to have a sign change. Don't see any other big surprises. 1 through 10, at least here, you are just distributing. There is no combining like terms. Once you get to number 11, you are doing some combining like terms also. And then 13 and 14 are like the end of our practice, where we distribute twice and combine like terms. Alrighty. The other page that you're seeing the top of, whoops, or you were, sorry about that. That other page here, maybe you were still seeing it when I made it disappear from my screen. This is just an additional order of operations sheet that we did in class. And so the first page is pretty straightforward. There are only 2 steps for each of these. And the next page is a little more complicated. There are multiple steps and square root is introduced. So a little tiny bit about square root. Square root, for instance here, square root of 49 is the inverse or the opposite of squaring. So we know that 7 squared is 49. So the square root of 49 is 7. So it does not mean half. Okay, it means you're thinking what number times itself could give me this answer. And roots are done in the same level as the exponent. Powers and roots are at the same level as exponents. I think it makes sense that we should get rid of that symbol before we try to work with that number that's underneath. All right, thanks again. If you missed class, I hope this was helpful to help you catch up.